In this class, we're going to consider what's called the discriminant for quadratic equations. So as a reminder, a quadratic equation is in the form of a quadratic expression equal to 0. So this would be your typical general form of a quadratic equation. Quadratic equations can have either 0, 1 or 2 solutions, and where they do have solutions, we either solve them by factorizing or we solve by the quadratic formula. So hopefully by this point you're familiar with both of those methods. But sometimes we're interested in only knowing how many solutions there are rather than actually finding the solutions. And we can use the quadratic equation to help us develop a method whereby we can determine whether we've got 0, 1 or 2 solutions. You can only have up to 2 solutions in a quadratic equation, but sometimes only have 1 solution, sometimes they don't have any. So you can always get the solutions to a quadratic equation by using the quadratic formula, even if the equation does factorize. Even if this here can be put into like 2 brackets and factorized, you could still get the solutions using the quadratic formula. It would be not advisable because it's going to take a lot more work in than just putting this into 2 brackets. So we can use the quadratic formula as a way of gauging solutions for every quadratic equation, not only the ones that don't factorize. But basically, if we look at the structure of the equation, we've got this term here, or this expression here, made up of the b squared term and the minus 4ac, which is living underneath the square root. The fact that it's under a square root puts certain conditions on it. So we're not allowed to square root negative numbers, for example. That means that if your b squared minus 4ac does come out to be less than 0, so if you put in the numbers and you process that and it comes out to be negative, then that's going to cause a problem because you can't square root a negative. So what that tells us is that at that point, if that was your scenario, then the quadratic formula is going to break down. But we've just said that the quadratic formula can be used to solve every quadratic equation. So that must mean that it's not that the formula is broken, it just means that in that scenario there are no solutions to that quadratic equation. So we would just say that that scenario there basically implies that you've got 0 solutions. If, on the other hand, the b squared minus 4ac value came out to be 0, then if that is 0, the square root of 0 is 0. If that happens, then that means that the plus and the minus disappear because you're adding or subtracting 0. But if you add or subtract 0, then you don't add or subtract anything. So effectively all of that would disappear in that scenario and you would just be left with minus b divided by 2a. If you've got minus b divided by 2a, then that means you're only getting 1 solution, because remember with the quadratic formula, the 2 solutions come from using the plus for one of them and using the minus for the other one. So if the b squared minus 4ac comes out to be 0 exactly, then that implies that we're going to get 1 solution for the quadratic equation. The only other option would be the more familiar probably to you scenario where the b squared minus 4ac, this part here, comes out to just be some number, some normal positive number, so greater than 0. And that's when we carry on through all the steps to use the quadratic equation, and in that case we get 2 solutions. So this thing here, the b squared minus 4ac, that's what we call the discriminant. Because of the nature of where it's located in the formula, under the square root, it's got this power to help us determine or discriminate between whether we're going to get 0, 1 or 2 solutions. So what it means is that if we look at these quadratic equations and we want to know whether it's got 0, 1 or 2 solutions without having to work through all the working, we just need to work out this bit, b squared minus 4ac, identify which of these scenarios we're in, and then just say whether we've got 1, 2 or 0 solutions. So it's quite a nice topic this. It's not particularly difficult. It's just really identifying your a, b and c values, working out this and then testing which of these scenarios you've got to deal with. Okay, right, cool. So that's the theory. Let's have a look at how this works in practice. So this first quadratic equation here, so the a value is 1, because that's the coefficient of the x squared term. The b value is 5 and the c value is 7. So we're just going to work up our b squared minus 4ac. So that's going to be 5 squared. I'll just write it out for this first one. 5 squared minus 4 times 1 times 7. I personally like to use the brackets to mean multiply. Otherwise, you've got to put in the multiplication sign, which is fine, but I don't know, personal preference maybe on that one. You've got the option to use brackets, put it like that. So 25 for the first number. 4 times 1 times 7 is 28, so minus 28. So that comes out to be minus 3. So that's a scenario where the b squared minus 4ac is negative, so less than 0. So that implies that this original quadratic equation has got 0 solutions. We also call the solutions sometimes the roots, so you might instead write that as 0 roots. Sometimes even further than that, your teacher might recommend that you write it as 0 real roots. It's beyond the scope of probably this class to talk about why they're real roots, but basically you get a number type called complex numbers, and complex numbers would allow for solutions to this equation even though there's no real solutions. Real solutions just means numbers based on the real numbers, solutions based on the real numbers, and the real numbers are just every number, apart from these complex numbers, which you might have seen before, but possibly not. So the important thing there is not so much the terminology, we got the fact that it's 0. No solutions to that equation, or no roots if we're using that terminology. Okay, so taking the same idea over to the next example, so our a value here is 2, our b value is minus 3. Always good to write down these values, I think, rather than just trying to keep them in your head. So b squared minus 4ac is going to equal minus 3 squared minus 4 times 2 times 2. Minus 3 squared is 9, remember, positive 9, because it's minus 3 times minus 3, so a double negative. Minus 4 times, well, 4 effectively is 16, so that's minus 7. So that one's come out to be negative as well. So this is, less than 0. So that tells us no solutions or no real roots. Again, whichever way you've kind of been taught to write that. Okay, so checking out the final example, just going through the same thing again. There's not really much variation usually to the process with these. So B is 6, C is 9. Just working through and seeing what we're going to get. So b squared minus 4ac, just working out that discriminant value, that's going to be 36 for 6 squared minus 4 times 1 times 9. So that comes out to be 36 minus 36, which is 0. So the scenario where we've got 0 for the discriminant is where you've got one solution or one root. So that would tell us, that would imply that we've got one solution to that equation, or one real root, as it might be written, or as you might be told to write it. Okay, so that's basically how discriminant works. One possible variation you might see would be things where, let's say for example, that term wasn't there. If that term wasn't there, then it would mean that the b value would have to be 0. Same with like if there was no number on the end, but say that x term was still back in there, then that would mean that the c value would be 0. So you can't have a value as 0 because you've got to have an x squared term in a quadratic equation, but you can't have a b or a c value as 0. And it's not that uncommon to get those to be 0. So just remember that if you see that, that still needs to be set to 0, and it will still need to be like sort of plugged into your quadratic, well, not quite the quadratic formula, into the discriminant part of the quadratic formula. So just a quick recap then, the discriminant is just a way of testing whether your quadratic equation has got 1, 2 or 3 solutions without having to actually work out the solutions. Sometimes in these questions you'll be asked to work them out anyway, maybe in addition to the discriminant. The discriminant just gives you this kind of quick method of determining how many solutions you're going to get. If you did work out discriminant and it told you one solution and you then worked out the solutions and you got 2, then either one part of the process has gone wrong because they have to be consistent with each other. But generally with these questions, they'll be fairly straightforward. and it's just a case of making sure you're careful with the calculation. Watch out for negatives, particularly on the b term, because remember the b is squared and a negative squared is positive. Also watch out if your a or c are negative, because then you'll be generating a double negative, potentially even like a triple negative here. So that's where I see a lot of mistakes with these questions, just getting the positive or negative wrong. So just be ultra careful as you work through them. If that all makes sense to you, then check out a few practice questions. Quite an important technique, this one, but quite an easy technique. You probably won't need too many practice questions before you're comfortable with it.